A motorboat travels the distance between 2 points A and B downstream in 3 hours, and a raft travels the same distance in 12 hours. How long does it take the motorboat to return? So, let T down is the time of travel the motorboat downstream. It equals 3 hours. And TR is time to travel the same distance for the raft. 12 hours. And let T up stands for the time of return of the motorboat. Time taken the motorboat to return from B point to A point. Let's make a picture. One side of the river, opposite side of the river, current. Point A, point B. Motorboat traveling from A to B. Motorboat traveling from B to A. And the raft traveling from A to B. We have times in the condition of a problem, but the only thing we can use is the formula for addition of velocities. V, velocity of the motorboat relatively to the Earth, boat relative to Earth, equals the velocity of boat relative to current, V boat, plus the velocity of current with respect to Earth, V current. The first case, the boat travels downstream, so these two velocities directs the same direction. That is why we can write that the velocity of the boat with respect to the Earth, V plus V boat plus V current. Two speeds are adding because these two vectors are in the same direction. When the boat returns from B to A, the velocity of the boat is in opposite direction, so the speed of the boat on the return equals V boat minus V current. This is speed relative to the bank of river, to the Earth. And at last, the speed of raft, the velocity of raft, and the speed of current, the velocity of current, are the same. V current. V current. Now we can connect these speeds with time using distance between A and B points. Let L stands for this distance. So we can write the velocity of the boat when it goes downstream equals L divided by T down. The speed of the boat when it returns from B to A equals distance divided by speed, L divided by time, L divided by T up. And at last, the velocity of the current and the velocity of the raft are the same, and we can write for the speed. Speed is a magnitude of velocity. Speed of current equals distance L divided by T raft. Well, now let's substitute the current into these two equations. We have from the first equation VB plus, instead of VC, we write L over T raft gives L over T down. The next equation, VB minus VC, substituting L divided by T raft is equal to L over T up. Now we have two equations, but we do not need VB in both equations. So let us do like this. This equation is number 1. This equation is number 2. Let's subtract the second equation from the first equation, term by term. VB plus the first minus the second. VB plus L over T raft minus VB, minus and minus gives plus L over T raft equals L over T down minus L over T up. We can see that VB eliminates, and in every term we have L in the numerator. So let us divide both sides of these equations by L. We'll have here L turns into unit over TR plus unit over TR, 2 over TR equals 1 over T down minus 1 over T up. One equation for one unknown. What is unknown in this equation? T up. This is unknown. So let us move this term into the left part of the equation and this term into the right part of the equation. We have unit over t up equals unit over t down minus 2 over tr. Now, let us bring these two ratios to terms to the common denominator. Unit over t up is t down tr tr minus twice t down. And the last step, let's find the inverse fraction. Exchange numerator and denominator. T up equals t down times t roughed over t roughed minus twice t down. That's it, the final expression. Substitute numbers into this expression. T up is t down 3 hours times t roughed 12 hours over 12 hours minus twice 3 hours. The result is in hours, and we have 6 hours. So it takes 6 hours the motorboat to return from B point to A point. The problem is solved.